This presentation is about Monintainer, our solution for monitoring container-based systems, which is an extensible and infrastructure-independent tool. This research is being done by a group of researchers from LACIG, a research laboratory from the University of Lisbon, in Portugal. Monintainer pushes the boundaries of monitoring tools in containerization ecosystems, surpassing the current state of the art. Before defining Monintainer, we extensively analyzed the containerization ecosystem and the existing monitoring tools within the field. This comprehensive evaluation allowed us to establish the specific scope of Monintainer, ensuring compatibility with the most prevalent tools in the containerization ecosystem, including Kubernetes, Docker, and others. Furthermore, we thoroughly assessed the functionalities and limitations of established monitoring tools such as Prometheus, cAdvisor, Sysdig, Elastic Docker, and numerous others. Based on these findings, we strategically designed Monintainer to address the shortcomings identified in the state-of-the-art monitoring tools for containerization ecosystems. Monintainer was designed to be an open-source project. It offers support for most of the prominent technologies in the area, and it can provide users with a holistic view of their systems in a granular manner through fine-grained profiling, which can be extended through third-party numerous solutions. The architecture of Monintainer comprises 4 distinct layers, each fulfilling a specific task related to data collection, integration, storage, and visualization. These layers are thoughtfully designed to meet the system's specific requirements, emphasizing modularity and extensibility. Any component of Monintainer can be horizontally scaled using load balancers, distributed databases, or stateless collectors. The collection layer comprises the node monitors, the core services like cAdvisor or PowerJeweler, and the agents. The node monitor aggregates data collected from each agent, while core services gather specific metrics such as container-related metrics and energy usage. The container agent, deployed for application, dynamically retrieves configurations and collects application-related metrics. The integration layer includes a REST API that enables users to manage resources, including agent configurations and metrics. These services offer essential tools for creating new configurations and updating or removing existing configurations for both monitor and agent components. The API bridges the monitoring and persistence layers, simplifying data transmission to a centralized reception point without concerns about subsequent processing. The storage layer is responsible for storing and accessing all data. It consists of 2 components: an InfluxDB database for storing metrics and a MongoDB database for storing agent configuration and processed metrics. This combined solution leverages the strengths of InfluxDB, which excels in storing and exposing time series data, while MongoDB enables a long-term storage and backup solution. Lastly, there is a gateway to retrieve data and facilitate the application profiling through graphical representation. The Monintainer user interface layer can be extended through API integrations, allowing clients to leverage alternative visualization tools and programmatic solutions that capitalize on the system monitoring capabilities of Monintainer. Monintainer makes use of configuration templates to configure the execution of collection components and scraping methods. The collector main template on the left is used to control the aspects of the execution of the collector and includes the definition of the fetch interval, the status of the collectors, its execution type, the endpoint to redirect the collected data, and the scraping mechanisms to use. The second template on the right is used to configure the metrics to collect in the corresponding scraping method, which includes the arguments to pass to the scraping tools, the custom labels, and a filtering field to filter exporters' metrics. This configuration can be used to scrape built-in metrics, system calls, shell commands, and Prometheus exporters. Monintainer is an open-source project and is publicly available at GitLab. The initial README introduces Monintainer context, its capabilities and differences from other projects in the monitoring area. In this README you have access to a detailed guide for setting the Monintainer components and the built-in metrics available for the collectors. A practical benchmarking example and its process is also described. Lastly, you can find the configurations used for collecting data from the benchmark executions. In the repository you can find the code for the developed components such as the API and collectors, and the documentation to guide you through the Monintainer components setup, as well as the description of the benchmarks that were used to test our solution. To demonstrate the capabilities of Monintainer, we ran a set of experiments. The experiments were executed in a cluster orchestrated by Kubernetes with 4 nodes. Services such as MySQL, Nginx, and Mosquito were deployed and used to demonstrate the functionalities of node monitors and agents. The benchmark tools used were Sysbench, Siege, and MQTT Benchmark. In this demo, we are going to describe the process of initializing collectors, gathering system metrics, and analyzing its result. For the benchmarks, we used 4 distinct configurations. The node monitor is the configuration for the monitors that will run in each of the cluster nodes. In this configuration, we set the endpoint address and port of the Monintainer API. The execution type is configured to be continue, which means the collector will execute continuously. The fetch interval is defined as 60 seconds between updates. In terms of scraping, this collector is responsible for scraping a set of metrics from the Prometheus exporter called Node Exporter, which was previously started. It is also responsible for collecting node and container-related metrics through the definition of built-in metrics. This node monitor is configured to collect metrics every 10 seconds. For the MySQL agent, the endpoint to report is configured with the address of its monitor. Besides, this collector is also configured with a continuously execution type and a 60 seconds fetch interval. In the scraping configuration, it is defined the built-in metrics to scrape in the required args such as the host, port, and credentials for accessing the monitored database. Moreover, the scraping periodicity is defined as 10 seconds. The Mosquito agent makes use of a managed exporter, in which the user defines the configuration for its containerization and the agent will start, manage and scraping that exporter. The exporter used is the Mosquito exporter and is one of many exporters available in Prometheus. This agent also has a periodicity of 10 seconds. The last agent is the Nginx agent. Like the other agents, it also reports to its monitor and fetch its configuration every 60 seconds. This agent is configured to scrape an endpoint that exposes metrics in Prometheus format. The defined periodicity is 10 seconds. For this demonstration, the Monintainer tool comprises 5 prepared dashboards for visualizing the node's performance and the services running in the cluster. However, we will start with empty influx and Mongo databases. As you can observe, the Monintainer bucket is clear. The dashboards are also empty as there are not metrics to visualize. The Monintainer components, such as databases and the API, are deployed in the master node of the cluster. In order to collect the node and container-related metrics, we will start the node monitors as Docker containers, which will fetch their configurations from the MongoDB database after its initialization and will start monitoring the infrastructure. Since we started the node monitor, we can now visualize the node metrics. For monitoring the services, we start by initializing the MySQL agent in one of the nodes for collating the MySQL database metrics. Following, we start the Nginx and Mosquito agent. Now the dashboards are completed. We can observe the node's performance, the service's behavior, and monitor our own API, which is running in a container, the master node. Now that the collectors are initialized, we are going to introduce some load into the deployed services to observe the performance behavior. This is done through a client machine, which is not part of the cluster. We are going to start with a load of 3 minutes of MySQL queries through the benchmark tool Sysbench. The clock in the right corner is a temporal reference for the execution of loads. Then we introduce some Nginx requests with the Siege tool, also for a period of 3 minutes. And lastly, we use MQTT benchmark to introduce some publish events into the Mosquito service. Now we are going to observe the behavior of the nodes, the services, and the Monintainer API during the period of this experiment. As you can observe, despite introducing small loads into the system, it is already possible to notice its impact in the node's performance. The node CPU usage. The temperature and the consumption presented some spikes when serving the client loads. However, since we finished the client simulation, the resource usage decreased. Now we are going to observe the services performance. We start with the MySQL respective dashboard, in which we can observe the increment of connections and various types of queries. The throughput seems constant now because we stopped the client load simulation. The same occurs with Mosquito and Nginx, as they registered an increment in their resource utilization, but after a period of time it becomes constant. The only dashboard missing is the API-related one. The number of packets received increased since the collectors are redirecting their collected metrics to the API. However, there are not dropped packets registered. Thank you. We appreciate your time listening to our presentation. The Monintainer tool is available for download at our repository, as well as the instructions to run our demonstration. If you have any questions or doubts, please do not hesitate to contact us.